Alright, we're going to start section 2.5, addition and subtraction properties. Our objective is to apply the addition and subtraction properties of segments and angles. The homework or classwork we're going to be working on tomorrow is on page 86 to 88, numbers 1 through 13 odd, 17, and 19. Please make sure you glance through this as we'll be working on them tomorrow. Alright, the first property we're going to talk is going to be our addition property. Now, this is the way our addition property is going to work. What it says is if congruent segments or angles are added to congruent segments or angles, their sums are congruent. Now, what does that mean? Well, let's make out a picture for that one. Okay, so here we go. Let's say that we have a picture that looks like this. So we have a segment with points A, B, C, and D on it. And here's what we know about this picture. What we know is that segment AB is congruent to segment DE, and segment BC is congruent to segment CD. Now let's put some tick marks in there. Let's put a 1 tick mark right here on the AB. Have a matching tick mark right here on the DE. And then let's put a double tick mark on the BC, and that's going to be congruent to CD, so let's put a double tick mark there as well. Now, just looking at the picture, I see that I have two sets of congruent segments. Now, what happens when I combine them? Let's look at it. Let's look at all the way from segment A to C and from segment C all the way down to segment E. And let's talk about that. I have a 1 tick mark combined with a 2 tick mark. Here I have a 1 tick mark combined with a 2 tick mark. What do you think we can conclude then? Well, when we add them together, we know that segment AC is going to be congruent to segment CE. Alright, so let's start talking about the addition property and how it works the second way. So here's what it says. If an angle or segment is added to congruent angles or segments, their sums are congruent. Now, this looks really similar to the last slide, but it's slightly different. So let's go ahead and let's make a picture out for this one. So, for this one, let's do an angle picture. So here we go. So let's say that we have angles here, labeled A, B, C, D, and E. Now first thing I do want to kind of point out over here is that we do have 3 small angles, 2 medium-sized angles, so it's angle EBC and angle DBA, and 1 large angle, angle ABC. Okay, now let's say this is what we know. Let's say that we know that angle ABE is going to be congruent to angle DBC. Now, let's go ahead and let's start putting our tick marks in there. So here we go. Here's 1 tick mark right here, angle ABE, and here's a 2nd tick mark here, angle DBC. Now, I want us to look at these medium-sized angles here. I want us to look at angle ABD and also angle EBC. What do you notice about them? What I notice here is that this pink one has angle DBC and this angle over here. And this red one has angle ABE and this angle here. They have an angular segment, in this case an angle, that's going to be shared and added onto it. So, the next thing that we can end up concluding is that angle ABD is congruent to angle EBC. We're just adding them on. Okay? So when I combine these, let's go ahead and overlap these. Oops, that's not quite what I wanted here. There we go. We have not only this angle with a tick mark, but this extra space here. And we have angle with a tick mark, and once again, that extra space piece. It's a common angle that's being added on. Alright, now let's start talking about the subtraction property. And here's what it's going to say. If a segment or an angle is subtracted from congruent segments or angles, the differences are congruent. Let's talk about what that picture is going to look like here. Let's use segments as an example here. So let's say that we're going to have 3 points on the line, A, B, D, and E. Let's draw a line going through those. And let's say that we know something. Let's say that we know that AD is congruent to BE. Let's throw those tick marks in here. AD, so you're talking a bigger segment here. Let me make that in black so we can see it. segment AD is going to be congruent to segment BE. What do you notice about those segments there? What I notice here is that we have an overlapping piece right here in the middle, segment BD. Now, what would happen if we take that piece away? What are we going to be left with? We're going to be left with the segment AB congruent to segment DE. The two pieces left, when we take out that overlapping piece, those are going to be what's going to end up being congruent by subtraction. Alright, so here we go. Second application of our subtraction property. Here's what it says. If congruent segments or angles are subtracted from congruent segments or angles, their differences are congruent. Now, let's talk about what that picture looks like, and let's use an angle for this. So, here's going to be our angle. Alright, so what I have here is I definitely have a total of 4 small angles here. We have some kind of medium size that are made out of 3 angles, EBC and ABD. We have some made out of doubles, ABF, EBD, FBC, and then we also got some big ones, ABC. Now, let's say here's what we know. Let's say that we know that angle ABF is congruent to angle FBC. Let's draw on that tick mark right there. ABF is going to be one of our doubles. It's congruent to angle FBC. It's another one of our double. Now, let's say that we also know that angle EBF is congruent to angle FBE. Let's draw on that tick mark as well. Angle EBF, that's going to be one of our singles, one of those little ones. And angle FBD, it's going to be another one of those singles. Let's look at that. We know big angles are congruent, and one of the little angles that makes it up is also congruent. So what's left over when we subtract it out? These angles right in here are going to be congruent. The next step that we can say by subtraction is that angle ABE is congruent to angle DBC. So here's some helpful hints for using the addition and subtraction properties. First thing that we have, the addition property is used when segments or angles are bigger in the conclusion than in the givens. So you're adding things. You start with little pieces, you combine them to make bigger pieces. The subtraction property is used when segments or angles are smaller in the conclusion than in the givens. So you start with big pieces and little pieces and end up with another little piece. Alright, so now we're going to try some examples. And may the force be with you. In case you didn't know it, I love pug dogs, especially when they're dressed up cute for Halloween like Darth Vader and Yoda. Alright, so now we're going to name the segment or angles that are going to be congruent by the subtraction property. So let's look at this first one right here. We know that the big piece, RT, is going to be congruent to the big piece, SV. What I see here is that ST is going to be an overlapping piece formed in the middle. What I'm left with is the smaller segment, RS, congruent to segment TV. All I did is I had to subtract out that common piece. Let's look at our next one, our angle application. So we know that the big angles here are going to be congruent. Angle WXZ and angle ABD. We also know that one of the 2 little angles that makes it up is congruent. What I'm left with are these other 2 little angles here. When I subtract out one small angle from the bigger angle, I'm going to be left with angle YXZ is going to be congruent to angle CBD. What do you think? Not so bad? I don't think so. Alright, so let's get started with our first proof. Angle BAD is a right angle, CA is perpendicular to AE, and angle BAC is congruent to angle EAD. So here we go. Let's have our statement and reasons. Let's start off by writing my givens. First given, angle BAD is a right angle. The reason? Given. Now, again, I feel that it's important to always draw out my picture. That way I can mark it up. I know BAD is a right angle, so I'm going to put my right angle marking. Next, we have that CA is going to be perpendicular to AE. That's also going to be given to us. Now, what comes directly out of perpendicularity that might be helpful for me? Well, what I can say here is I can say that angle CAE is a right angle. And the reason? I'm using that key symbol, perpendicular, and I'm using its purest definition, so I can say definition of perpendicular, and I can put my right angle marking right in there. Now, both my angles are right angles. What can I say about them? I can say that they're congruent. Angle BAD is congruent to angle CAE. Now, what's my justification? We should have, if two angles are right angles, they are congruent. Alright, now, we know that those bigger angles right here are congruent, and I see that I'm overlapping right here in the middle. If I take out that overlapping piece, what am I going to be left with? I'm going to be left with my smaller angles, BAC, congruent to angle EAD. And my reason? Subtraction. Hopefully you felt pretty good with that proof. Wasn't too bad. A little tricky in here with those two steps, but overall, that was pretty good. Alright, here we go. Next proof. We're given that angle HEF is supplementary to angle EHG. That angle GFE is supplementary to angle FGH. We have two sets of congruencies. Angle EHF is congruent to angle FGE. That's written with these angles with one little line going through them. And also, angle GHF is congruent to angle HGE. Those are the double tip-lined angles. Now, here's what we're trying to conclude. I'm going to go over them in blue and purple. We're going to end up trying to conclude that angle, let's make that a little smaller, that angle HEF, that angle over here, is going to be congruent to angle GFE. GFE. There it is. And let's start our two columns, and let's throw our givens in there as well. So here we go. Alright, so here we go. Remember, if you need a second to pause to make sure you can have this stuff written down, let's go ahead and let's do that. Now, let's talk about what we have. Let's look at this picture. What I see here is I have two small angles with tick marks and two small angles here with identical tick marks. When we see those identical tick marks, we know we can add them up. And I can end up with angle EHG being congruent to angle FGH. And that's going to be by addition. Now, we're going to look for things that are going to be repeated. Now, anytime we see supplementary written twice, we want to kind of look for repeats, and I'm going to try and circle those. So my first set of repeats. In my first supplementary step, I have angle EHG, which I see was repeated in a congruency step right here. I also see angle FGH. That was repeated right there as well. If we start crossing them out, and we look at what's left in that supplementary line, we end up with angle HEF being congruent to angle GFE. Now, do you remember what that theorem was? We used it earlier in the chapter, and here's what it said. It said if two angles are supplementary to congruent angles, they are congruent. Now, you'll notice as we keep continuing with our proofs are going to get longer. They're also going to require you to remember those theorems and properties that we used in other chapters. This might be a good time to kind of go back in our notes and tab some of those theorems and properties that we've been doing, just so that we have them as a resource. Now, last but not least, for tomorrow's classwork, I included the answers here. The answers to the different problems that we're going to be going through. Special request from my 8th hour asked if I could include these in the back of our slides? And I said, absolutely. If you want to copy these down, go ahead, press pause, let's write them down. We got to make sure that we can get those answers. Remember, that's going to be our number one goal here, is to be able to arrive at those answers. If you need them again tomorrow, let me know. I'm more than happy to put those up as you're going through your work. But otherwise, let's look through those problems, make sure we feel pretty comfortable doing them, and we're going to get rolling on those tomorrow as soon as we enter into class and clean up any questions that we have here. Have a good one.